Hello, everyone. Welcome back. Today we are going to be talking about log ingestion and how it is so important to know for the CySA Plus and just in general for being a cyber analyst. What log ingestion is, if you look at my overview, log ingestion is the foundational process of collecting, parsing, and importing log data from various sources into a centralized security monitoring system, typically a SIEM, System Information Event Management System. This is a critical skill for cybersecurity analysts. Logs provide the raw data needed for threat detection, incident response, and compliance reporting. By the end of this module, students will be able to define what log ingestion is and explain its role in security operations. Identify common log sources and formats. Understand the log ingestion pipeline process. Recognize the challenges and best practices in a log collection. Configure basic log collection scenarios. Log ingestion is the automated process of collecting logs from multiple sources across IT infrastructure, parsing the raw log data into structured formats, normalizing different log formats into consistent schemas, enriching logs with additional context, geolocation, threat intel, storing processed logs for analysis, and retention. Think of it as the data plumbing that feeds your security monitoring systems. Some of the common log sources in network infrastructure, you'll commonly see firewall logs for connection attempts, block traffic, rule matches. So any block connection, any failed connection attempts will show a log in the firewall. For routers and switches, it will log different routing changes, the interface status, and simple network management protocol. Simple network management protocol data. Load balancers, you would get the traffic distribution, health checks, secure socket layer termination. DNS servers would query the logs, zone transfers, and resolution failures. So if when you're typing in a domain name and it doesn't go to anything, it would log that it didn't go into anything. For security devices, an intrusion detection system or an intrusion prevention system would log intrusion attempts, signature matches, anomalies, antivirus and endpoint detection and response, malware detections, quarantine events, scan results. For a data loss protection system, it would log data exfiltration attempts and policy violations. For authentication systems, like where you would type in your password and it would say, or a local account that they're trying to log into, it would show those login attempts, failures, privilege escalations. It wouldn't show privilege escalations. You would have to diagnose down to figure out how it was privilege escalated. It wouldn't directly say, this is a privilege escalation. You would have to figure out how the person elevated their privileges and stuff through different logs and stuff, like authentication attempt, login attempts, failures, stuff like that. So if someone logged in, you could see what time they logged in and stuff like that if you had logging on. But for operating systems, you'll sometimes see Windows event logs, security system, and application logs. For Linux system logs, syslogs, you will often get authentication, which is successful attempts or failed attempts. Kernel messages like DMSEG, dmessage. Application logs that come from whenever you are actually in the application. macOS has system logs, security events, and application crashes. So if your application crashed, it would log that and help you diagnose why it crashed. For applications like web servers, you'll get access logs, what people were doing whenever they were accessing stuff. Error logs like errors in the code and stuff. Performance metrics, which is like how the website's doing, how many, like the management dashboard for the web server, the back end of the web server. The back end of the web server will be giving the information into that dashboard. It'd be pulling from that backend. For databases, query logs, which are you querying to it, sending commands to the database to pull stuff down. That's why SQL attacks are prevalent, because people could get passwords and stuff from SQL attacks. That's why it's really important for you to actually input validate your input. Anywhere someone can put input, it's very important that you really crack down on those so that people can't do SQL attacks on your websites or be able to access your databases. Query logs, we already talked about that. Authentication, so that would be for when you're accessing the databases from the database manager and logging into the database so that you're actually able to use it. But web servers just pull stuff from it, so that's why SQL attacks are allowed to happen, because people haven't cracked down on input validation. For schema changes, that would be like different changes that have happened to the database. It would track that if you used Git and stuff like that, version control. For email systems, it would track message flow, how the traffic is being redirected and stuff like that. It would also detect spam and different security events that may have happened. Sometimes even saying this is spam or saying that this is a phishing email so that you know not to click anything in it. For custom applications, we have business logic events. So how the logic works and relates to business processes, that's what it would log. For user actions, it would actually log what those users were doing on the applications. For errors, it would just log any errors that these applications are throwing, like programming or coding errors. Here's what a syslog looks like. You get su root, so they were trying to escalate their privileges in Linux to root. So this is the user that, just a random user that tried to do this command right here on this TTY terminal editor or terminal instance. For this is what a Windows, so if you're in Windows Event Manager, you might get XML data from this. So this is telling you what time it was created, stuff like that. Saying what event up here. So it's saying this is the schema, this is the event that happened. Ceph is used to detect like stuff from like your XDR, your EDR, and your XDR. So for JSON, that is becoming a lot more popular and a lot more used, and it detects, hey, someone was trying to do an XML attack on this website. It would log that, or it will log authentication failures and stuff. For this is how the collection process works, the pipeline of the route that the log data would take for certain scenarios. Push versus pull. For push, the source would send logs, versus if it pulled it, it would collect and retrieve them. So you might be pushing it to a seam tool that puts all these logs in so it's all in one place. So you might be pulling from different places. That's where send would come in. When you're sending logs to your seam, when you're collecting them or trying to retrieve them, you might be trying to retrieve them on one of your computers that you're not trying to connect to it from your seam. So for collectors, you're trying to get that log data immediately to collect it and use it. That's the difference between these two. Real time versus batch. Real time is actually streaming that data over. Batch isn't, so think of UDP and TCP. TCP is going to be more scheduled because it takes a little bit longer. But UDP is like real time. It's actually sending the data packets. It's sending the data packets. That would be like if you're watching a live stream. That would be using UDP. Versus if you were just watching a recorded video, that would be TCP. For transport methods, it can be transported via syslog, HTTP, HTTPS, which HTTPS is the secure version. File transfer. So this is how it's being sent. It's being transported. These logs are being transported. It might be transported via database query. For parsing, you are actually, extracting that data, identifying different things so that you can parse everything out and organize it better. Like different things like the timestamp, the source IP of the log, the destination IP of the log, message components. This all ties together into parsing and into log digestion. For data type recognition, converting strings to numbers, dates, and IPs. So this is converting the strings to numbers. It's converting the dates into a readable format. For pattern recognition and pattern matching, you'd be using regex or parsers for structured extraction. Regex is used to parse that data and parse it correctly. And you also have other parsers and stuff that you could use for the extraction of that data. Extracting, hey, this is a date. I need to put this in this place. Or this is an destination IP. I need to put it with the destination IP section. For normalization, you'd be converting different formats to unified structure. This means one format might be different than the other. You want it in this format. So say I did the month, the date, but they were in numbers. Say I wanted the month in letters. This normalization would normalize that and say August or say December instead of saying 12 for December. For field mappings, this standardizes the field names. The names that a field of data, which is one piece of data. So it's standardizing what those names are and how they would correlate to different structures. For time zone handling, they are converting your timestamps to whatever your time is, so that you are getting real time and you're actually knowing what time it is when certain things happen. Because say something happens that was in a different country, their time's going to be different, so those times wouldn't line up. So converting it would actually help you, because different time zones are different and different countries are different. For enrichment, you get like geo IP lookup. So this would be able to extract the location from IP addresses. Threat intelligence. This is marking down bad IPs, known bad IPs, domain names, and hashes so that you can block them so that they can't send malware. Known bad IPs, which the IPs could have malware on them. So you're not going to allow those IPs to send you anything or even able to connect to it. That's why we need to build up our threat intelligence so that we're better about stuff like bad IPs, bad actors that are trying to, take away and give us some malware or just anything so that they can extract data. They can do all the bad actor stuff. For asset information, this is going to talk about who owns the asset, what is the device name, who named it, which would be the owner who named it. Criticality. How damaged is this asset? Is it does it have malware? Does it need patched or something? So that is the asset information. Hey everyone, in the next video we will be talking more about log ingestion. Please subscribe and share this video.